Okay, now come to the next topic, function. This function is really very important part because it will use in class 12th also. So go through the video in proper manner, and first of all we have to understand and what type of relation is not a function, because we know that all functions are a relation. All functions are relation, but all relations are not a function. First of all, we have to consider and we have to understand and what type of function is not a function. What type of relation is not a function. Now see, suppose this function, and till our previous exercise we are writing here f. Now we have to write f. Suppose a and b are the two sets and some element, right? 1, 2, 3, 4, and here a, b, c only. This element having the image in b and 2 having a. This is this, like this. But 4 is the element of a, but 4 doesn't having any type of image in b, and such a relation is not a function. Although this is a relation, but this is not a function. The reason, because 4 is belonging to a, but 4 does not have any type of image in b, so such a function is not, such a relation is not a function. Functions are the set of relation also, but the function, this relation is not a function because 4 is belonging to a, but 4 doesn't having any type of image in b, so this is not a function. Number 1. Number 2, this is b also. 1, 2, 3, 4, and here a, b, c only. Now see, one, 2, 3 is here, A, B, C, D is here. Now see, one element having two images. One element, one having A and B. But in relation, this relation is possible, but function is not possible. Because one element having two images in A and B, so this is not possible. Because one is the element and having the two images A and B, and such a function is not possible. These two types of functions are not possible. One, if any element in the ordered pair, the first set in the ordered pair, if any element having doesn't any type of image in B, such relation is not a function. And second, in the ordered pair, the first set having any one element having the two images, and such a relation is not a function. And the rest of all are the relations. And first of all, go through these two. After that, we will start. And there are so many other functions also. I am writing these one things, but you have to keep in mind. First of all, note it down. Then you will start next things. These two are not a function, and the rest of them are function. And first of all, I am going to one function. One function means one element having only one image. Now see, this one. This is f function a, b. 1, 2, 3, 4. A, B, C, D, E. No problem. A, 1 having the image at B, 2 at B, 3 at A, 4 at this one. One element having the one images. Now see, here, and this is the function. The reason is that in the first set, all elements having at least one of the image in set B. But B having is the element of B. But A is not image of any one set of these one things. This is possible. So this is 1 function. But keep in mind one more thing. Suppose this A is here. A is not a image of any element of A, and this is known as into function. This is known as into function also. Into function. And since one element having one images, one element having one image, and this is known as injective function. Injective. injective injective function into function. And what is the meaning of onto function? Into means if in set B, if any element who it's having no pre-image is known as into function. If suppose this is not, E is not here. Now suppose this is, it means this is onto function. This is 1 onto function, and this is known as 1 onto function. But we are writing here E also. This is known as 1 function, into function. This is also injective function. Suppose I am rubbing this one thing. This is also known as injective function. This is known as 1 function. Now come to onto function. Second, F, A and B. 1, 2, 3, 4, 5. A, B, C, D, E. And two elements having one image. This is possible. This function is possible because two elements should have one image. But one element doesn't have two images. This is not possible. And two elements having one image, it's possible. This one is like this way. This is this like. A is right. Now, all elements of A having the images in B, and B is no element who having the pre-image in B. All elements are engaged by every one elements of set A. Means this is known as the first order pair. This is the second order pair. All first order pair, all elements are engaged to all elements of the second order pair, and we don't have any type of element in B and which is free from the image, and this is known as onto function. And this is known as surjective function. Then third one is 1 and onto function. Now see, 1 and onto function. F, A and B. 1 by just name is also defining everything. 1 is every one element, one image, and onto means no element will be left in set B. So 1, 2, 3, 4, 5. A, B, C, D, E. So the elements are attached like this manner. One element having one image, and in set B no element is free. So this is known as 1 and onto. 1 and onto is known as, because this function having the two properties. Number is 1 as well as onto. This is 1 and onto. By combining both these function 1 and onto, and we are getting 1 onto function. This is known as bijective function. This is known as bijective function. This is really very important. And suppose, now come to the first again. These functions are very important, and you will get very benefit in class 12 also. Suppose we will flip this one things. Instead of B and A are flipping to E. Flipping means if all the elements of B are converting to A and A is converting to B, then what will happen? What will happen means all the elements will go there and these elements will come here and E will be left. But we know that if in set A, if any element which is having not the image in set B, and this type of function is not possible, it means this function means if we will flip these elements, so this function is not will be a function. So this function is not an invertible function. We can't invert like the same manner. Suppose if we will flip this one things in this one onto function, all elements of B is converting here and these elements are coming here. Means now see, A should will have the two images. A having the two images, which is not possible. So this is not possible also. Invertible, this is not invertible. Now we will come again in this set, and suppose if we will convert this one things, B to A and A to B means all having the 1 1 and on 2, and this is also known as invertible function. This is invertible function. This function is also known as invertible function. After these three functions, these three are really important function. After that, the next function is, I already this one is, next function is, now see, manual function. Manual function, fourth. Manual function. Manual function means, suppose the function is this one, other function is this one, this is A and this is B. 1, 2, 3, 4, 5. A, B, C, D. And so many elements are attached to a single element. Now see, these two elements are also attached with them. And this is known as manual function because so many elements are attaching to this one and this one, and these two elements are free from the images of any element of A. So this is known as manual onto or into. Into will come because these two elements are free. Into. And one more, fifth one is constant function. Constant function means A, B, 1, 2, 3, 4, 5. Suppose A is there only. If all elements having the same image at A, it means this function is not depending upon the value of x, is known as constant function. Suppose f of x equal to 3 only. The function is not depending upon the value of x, is known as constant function. Then come to the next function. Then come to identity function. Identity function means a function. Suppose y equal to f of x and x equal to x. It means y equal to x. Whatever we have in the value of y, and this is the same as x. So y equal to x, it will draw the graph. And we will get the graph like this way. This is x-axis, this is y-axis, this is y equal to f of x. For the different value of x, and we will get the same value of y also. This is known as identity function. And 7, what is the new function? Ordinary function, you can start this thing. Then modulus function. This is very important function. Modulus function. Modulus function is f of x equal to mod of x, and mod x means having the two values, either minus x or plus x. This is if x is less than 0 and if x is greater than 0. It means f y equal to this one. This is just denoted by y. Y equal to f of x equal to mod x, either minus x or plus x if x is less than 0, if x is greater than 0. If you draw the graph, we will get the two lines. Number 1, y equal to minus x, we will get. Number 2, y equal to plus x, we will get. Y equal to minus x means we will get the graph like this way. Y equal to minus x. And for the y equal to x, you will get this graph because this is of less than x and greater than x. And f of x equal to plus x. These are known as the modulus graph, modulus function. And suppose any more, suppose one more. See, f of x equal to mod of x plus 1. Now how we can draw the graph of this mod of x plus 1? Now see, it can be minus x plus 1. If x plus 1 is less than 0, means x is less than minus 1. If x is less than minus 1, and it will come plus x plus 1, or if x is greater than minus 1. It means when we will draw the graph and it will cut, it will turn at -1. -1 means here. This is 0, this is -1, this is -2, this is 1, this is 2 at -1 because -1 is the critical point where the graph will break like this way. This is known as f of x equal to minus x plus 1 and this is f of x equal to plus x plus 1. And like same, the so many other modulus graph have been given in your books, and just I'm starting a new function. And the next one is signum function. Signum function means a function is defined in such a manner that f of x equal to either -1 will come or 0 will come or 1 will come. -1 means if the value of x is less than 0, if the value of x is 0, and if the value of x is greater than 0. If you will draw the graph like this manner, now see, this is x-axis, this is x negative, this is x positive, and this is y negative, and this one is known as 0. For x, f of x equal to -1, either -1 means the value of x is -1 towards this side, and this is known as y. Y equal to -1, y equal to -1 here. If the value of x is less than 0 means towards this side will come. And if y equal to 0 means this point will come. And if y equal to +1 means y equal to +1 will come here. And if x is greater than 0, x is greater than means towards this side. And this function is known as signum function. After that, one more and very very important function is there also, which is known as greatest integer function. Greatest integer function 9. Greatest integer function. Greatest integer function is denoted by mod greatest integer function like this way in square bracket x, and its value is known as less than or equal to, less than or equal to in integer. Now see, suppose 3.1 I have written. 3.1 means what is the integer of that? Integer means only 3 is the integer, 0.1 is the decimal number, so it will come 3. Suppose 3.0 will come again 3. 3.9 means integer. What is the integer? Only 3, so it will come 3 again. Suppose 3.8, only integer part is 3, only 3 will come. Like the same manner, suppose 4.9 I am writing here, less than just 4.9, just less number of this one things, and which will come towards left side. Towards left side means -5 will come. In this number line system, suppose we are drawing these things in the number line system. Suppose this is x, and this is x dash, and this is y, and this is y dash. This is 1, 2, 3, 4, -1, -2, -3, -4. If any number will come less than 1 means all number will come as 0. Because till 0.9, suppose I am writing here 0.9 means what is the integer? The integer is 0, 0 will come 0. And 1 to 1.99 means all number will come like this line. 2 to 2.9, all number will come at 2. 3 to 3.9, all number will come at 3. Like the same manner, all these numbers will come like this way. All numbers. And this is known as greatest integer function. Means less than or equal to. Less than or equal to. And these all are the function, the different type of function which is given in your syllabus. And first of all, you have to learn all these functions. 2 more functions have been given in your book. We will go through the books, because one is polynomial function, and other is reflexive function, and you can go through the books. and you can understand better way. And first of all, learn all these functions, and after that you can start the numerical questions, whatever given in your books. Okay, now today we will start the exercise 2.3 NCERT questions. Question number 1, it is given the given relation is a function or not, and I already discussed with you, means all the relations, all the function will be a relation, but all relation is not a function, and we have to define, and these given relations are the function or not, and which of the following relations are function. Now see, 2, 1, 5, 1, 8, 1, 11, 1, 14, 1 and 17, 1 is given. So for determining these things, this is really a function or not. And first of all, we can draw this first element. This is 2, 2, 1 and 5, 2, 1 again, and 8 is again 1, 11 is also 1, 14 is also 1, 17 again 1, means all the elements having the image at 1. Hence we know that this type of function is known as constant function. Yes, this is the function. And the second one is 2, 1. 2, 1 is 2, 1, 4, 2. Wait, 4, 2, 1, 4, 2, 6, 3, 8, 4, 10, 5, 12, 6 and 14, 7 is there, and we have to find this relation is a function or not. For that we will write these things. This function a to b, here 2 having the image 1, 4 having the image at 2, 6 having the image at 3, 8 having the image at 4, 10 having the image at 5, and 12 having the image at 6, and 14 having the image at 7, means this is known as 1 function. Yeah, this is also a function. And its third part, come to know, as a third part, this is 1, 3, 1, 5, 2, 5. 1, 3, 1, 3, 1, 5 and 2, 5. 1, 5 and 2, 5. Directly we can consider about it now. See, this is function. Here 1 is to 3 and 1 is to 5 again, means 1, 3 and 5, and 2 to 5. 2 to again 5. Yeah. We can write these things like this manner. 2 to 5 again. According to the given question, it is given that now see, 1 having the image at 3 and 1 again having the image at 5 and 2 having the image at 5. It means that such a function is not defined, because you know that if any one element having the 2 images in the order pair of the second set, then this type of function is not possible. So we can write these things, this is not possible, and the rest of these two, first and second, are the function, but rest of these things are not a function. Question number 2. This is find the domain and range of the given function. Number 1, f of x equal to minus modulus function of x. So now see solution and how we can find these things. And first of all, suppose we will put the value of x equal to different item. Suppose 0, 1, 2, 3 and so on up to infinity, and we can start this thing from minus number also. Suppose minus 10 is there. Suppose then it will come minus mod of minus 10, means minus will be there and minus 10 will come 10. It will come minus 10. And suppose we are writing its values minus 100. It will come minus into minus 100, means minus 100 will come. And suppose we are writing its values positive 100. It means positive 100 will come and minus 100 will come again. It means suppose we will put any values of this one, x, f of x equal to suppose 1000 we are putting here, minus 1000 it will come. It means it will come minus 1000. It means we can put the different values. So domain of this number, domain is equal to all real numbers. The domain is belonging to all real number. Why? Because we can put the domain values is different one. Minus infinity to plus infinity are all real numbers. So domain is a real number, and range, suppose we are putting here f of x, x can be written 0. It means minus mod of 0 means 0 will come, and the rest all negative number will come. Hence range must become minus infinity to 0, and minus infinity always kept in small bracket, and this will come the closed bracket, and so its range will come like this manner. And its second part, that these questions means to finding the domain range is most important. So many questions have been given in your books as well as in the different books also. Then the next second question is very important question. Now see, f of x equal to under root of 9 minus x square. Domain means value of x, and it can be denoted, f of x can be denoted y also. For domain, solution. For domain means domain. The function will define if its values means 9 minus x square must be greater than equal to 0 if any function have been written in the form of square root inside of this bracket, and it should be greater than equal to 0. And suppose this values is less than 0, it means this value will not define, it will come imaginary number. Okay, so 9 is greater than equal to x square, hence x square is less than equal to 9, so x square is written as 3 square, so x is either greater than minus 3 or this one is plus 3, means its domain will come minus 3 to plus 3, but its range, how it will range will come, and the value of y, suppose x equal to minus 3 3 is a 9 will come, its value will come 0, so y will come, suppose y equal to minus 3 minus 2 to all values of plus 3 if you will write, then we will get y equal to, suppose we are putting here minus 3, 9 minus 3 is a 9 means 0 will come, and y for the different values under root of minus 2, 9 minus 2 is a 4, root 5 will come. By putting all these values we will get its range we will get 0 to only 3 will come, 0 to 3 will come, I think. Am I right? Okay. Because the range will come 0 to 3. If x equal to 0 means it will come, its value will come 3. And if x equal to 3, its value will come 0. Right? So this is known as range of the function. And one more thing is now. Suppose any question have been given to like in this manner. Suppose the function is given in this form. Now see, in which form? In this form. Suppose f of x equal to 2x plus 7 upon x minus 1. Suppose this is the function, and how we can find its domain and range? For finding its domain and range, the function will define if its denominator will not equal to 0. For domain fx minus 1 is not equal to 0, it means x is not equal to 1, means all the real number but except 1. So domain will come r minus 1 will come. This is the domain part. Or finding the range means f of x, we can put it y. So y is equal to 2x plus 7 over x minus 1. We can solve this equation for the value of x. The cross multiplication yx minus y equal to 2x plus 7. So yx minus 2x is equal to y plus 7. X is common. Y minus 2 equal to y plus 7. Hence x is equal to y plus 7 divided by y minus 2 will come, and this one function is denoted by f of y equal to y plus 7 upon y minus 2, and the function will define if y minus 2 is not equal to 0, y is not equal to 2, so range will come Range means all real number minus 2. This is the range of this function and this is the domain of this function. And suppose the function have been given to you in this form, numerator and denominator, then we will write for finding the domain of this part, its denominator will not come 0. And for range, first of all we have to solve this question for the value of x, and you will get the value of x in term of y, and x can be written f of y. Then the function will define if y minus 2 is not equal to 0, y minus 2 is not equal to 0, it means y is not equal to 2, then range will come all real number minus 2. Okay. Now question number 3. F of x equal to 2x minus 5 is given. We have to find the value of f of 0, f of 7 and f of minus 3. So for finding the value of f of 0 means in place of x you will put 0. X equal to 0, then f of 0 will come 2 into 0 minus 5 equal to 0 minus 5. It means minus 5 will come. And the same way you can put the value of 7 instead of x equal to 7. Then f of 7 will come 2 into 7 minus 5. 7 to the 14 minus 5 equal to 9 will come. For x equal to minus 3. So f of minus 3 means 2 into minus 3 minus 5 is coming. 2 3s are minus 6 minus 5 means minus 11 will come. This is the answer of this question number 3rd. And same way we can solve the question number 4. This is very simple. You can solve the question number 4. I am not solving the question number 4. Very simple. And come to the question number 5. At least in one question you should try to solve. Now see, f of x equal to 2 minus 3x. F of x is equal to 2 minus 3x. 2 minus 3x. X is belonging to real number. If x is belonging to real number, what will be the range of the function? Now see, if domain of its part. Now see, first of all, domain. Domain is belonging to real number. And range. Now see, for finding the range will come, at least its value will come. If x equal to 0 means its x equal to 0 means 2 will come. X equal to 1 minus 1 will come. It means its value will decrease. 2 is maximum value and the rest of the value will come down. Minus infinity to 2 will come. But how? Now see. If f of x is defined 2 minus 3x, if x equal to 0, then you can put x equal to 0. 2 minus 3 1 that 0 will come 2. Suppose in other number rather than 0, suppose we are putting here f of 1. So 2 minus 3 1 that 3 means minus 1 will come. F of 2 means 2 minus 3 2 is 6 means minus 4 will come. F of 3 and 2 minus this one. 2 minus 3 2 is 6. 3 3 is 9 minus 7 will come. Question number 5th. Next question. F of x equal to x square plus 2, where x is belonging to real number. Or for this question, its domain will come real number because already x is given the real number. And for finding the range issue, we find f of x equal to x square plus 2. This is directly shown as x square. Means if negative number will come, its square will come positive number. If positive number will come, its square will already come positive number. So I have put here x equal to 0 means its least value will come. F of 0 equal to 2 will come. 2 is the minimum value of this function. Then for the other values, x equal to plus minus 1, plus minus 2, plus minus 3 and plus minus up to infinity, and for all these values the function will come all positive number and which is greater than 2. So the range of the given function will come 2 is the minimum value and up to infinity will come. So this is the range of the given function 2 comma infinity, and the rest third part you have to try this one question. Come to the miscellaneous exercise of this one, relational function. The function is defined by the two functions f of x equal to x square, and if x is greater than equal to 0 but less than equal to 3, and its second part 3x if x is greater than equal to 3 but less than equal to 10. One function. And second function gx is defined x square if x is lying between 0 to 2 and 3x if x is greater than equal to 2 but less than equal to 10. And we have to prove that fx is a function but gx is not a function. Means solution. How we can find these things? We can define these things because now see f of x is the function f of x. We can put the value 0 to 3 means 0, 1, 2, 3. X, f of x means x square means 0 to 0 will come. If f of 1, 1 means 1 1 ja 1 will come. 2, 2 2 ja 4 will come. 3 3 3 ja 9 will come. Okay, this is the function. And for gx, another diagram we can prepare like this manner. This is gx. Here 2 2 2 and means here also f of x is like this way, and here also if x is greater than equal to 3, greater than equal to 3 means if f of x equal to 3, 3 and 3 3 is 9, 9 will go right. If x equal to 4, 4, 4 3 is 12. If x equal to 5, then 5 3 is 15. Like the same manner, and we can solve, and this function will represent a function. But for g means second one function. If 0, 1 and 2, 0, 1, 2, this function will like so 0 0 is 0, 1 square, 1 1 is 1 will come, and 2 2 2 is 4 will come. Then that's just 2. Again for this function 2 2 3 is 6 will come. And suppose 3 3 3 is 9 will come. And so many other functions will come now. But we know that if any element, any one element having the two images and two having the image 4 and 6, so this is not a function and this is a function. Because this is only a one function, one element having one image, and here one element having the two image, and such a function is not defined. Therefore, f of x is a function, gx is not a function. F of x equal to x square. The question is defined f of x equal to x square, and we have to find the value of this one function, f of 1.1 minus f of 1 upon 1.1 minus 1. Solution. F of 1.1 means this is just like f of x square. This is defined by 1.1 square minus 1 means f of x 1 square upon 1.1 minus 1.0, and we can apply here a square minus b square, directly we can solve a square 1.1 minus 1 and 1.1 plus 1 divided by 1.1 minus 1.0, and this will cancel. 1.1 plus 1, that is 2.1 is the answer. Next question number 3. Find the domain of the function f of x equal to x square plus 2x plus 1 upon x square minus 8x plus 12. If the function will define, means I already discussed, if the function is defined, its denominator will not come equal to 0. So x square minus 8x plus 12 is not equal to 0. Then we can factorize or we can find the value of x square 8x by middle term splitting. Factor of 8 whose product is 12. This is minus 6x minus 2x plus 12 is not equal to 0. Common x minus 6 minus 2 is common. X minus 6 is not equal to 0. X minus 6 again common. X minus 2 is not equal to 0. It means x is not equal to 2 as well as 6. So domain of the function, domain will come all real number minus 2, 6. This is the answer of your question. And these type of questions have been given, and you can solve these questions also. And like the same manner, so many questions have been given in your NCERT books, and I will send one assignment paper also, and you have to solve these questions whatever given in your NCERT books, as well as I will send the 20 to 30 questions I will send also, and you have to solve all these questions in your notebooks. Okay, and just in second day, and I will start the trigonometric function. And before that, and very soon I will send a message to you for your live classes. Although continuously today we got not success, but 100% I will tell you, and the day will come when you will success by your live classes. Okay, thank you.